So here is half past paper, week 8. These are all the topics that we're going to be doing today, all the even numbers of the past paper. It's a non-calculator paper, so let's get into it. Right, 0.73 as a percentage. So percentages are out of 100. With 0.73, we can write that as 73 divided by 100. It's 73 moved over 2 place value columns, and that's going to be 0.73. So 73 out of 100 is the same as 73%. If you want to go from a decimal to a percentage, you are just multiplying by 100. And likewise, if you wanted to go from a percentage to a decimal, you are dividing by 100. For question number 4, write down a prime number that is between 20 and 30, and they love to ask you this. There's 2 prime numbers between 20 and 30, and they are 23 and 29, and you could have either of those here. So remember, a prime number is a number that's only in the 1 times table and its own times table. So it's only got 2 factors, 1 in itself. No other numbers fit into it a whole number of times. So 25, for example, that's not prime because that's in the 5 times table. Question number 6. Harry is planning a holiday for 4 people for 7 days. Here are the costs for the holiday for each person. Travel's £150, hotel is £50 for each day, spending money is £250. Work out the total cost of the holiday for 4 people for 7 days. So we've got each person £150 for travel, and then for the hotel it's £50 for each day, but we're there for 7 days, so we need to times that by 7. 50 times 7, 7 times 0 is 0, and 7 times 5 is 35. So that's £350 for the hotel for 7 days, and spending money is £250. So each person, if we add that together, 5 add 5 add 5 is 15, so 5 carry the 1. 1 add 3 add 2 add 1, that is 3, 4, 5, 6, £750 per person, and you've got 4 people paying that. So you could absolutely just do 750 add 750 add 750 add 750 if you're more comfortable with that. I'm just going to do 750 multiplied by 4. So 4 times 0 is 0, 4 times 5 is 20, so 0 carry the 2. 4 times 7 is 28, add the 2 is 30, so that is 3,000, and that is for 4 marks. Question number 8, write the following fractions in order of size, start with the smallest fraction. Now it's really hard to compare fractions if the denominators, the bottom numbers, are different. If we can make them all the same, it's going to be really easy for us to compare them. So ideally I'm looking for a number that's in the 3 times table, the 4 times table, the 12 times table, and the 2 times table. And that's going to be 12. You could choose 24 or any other number that all those numbers can multiply to make. 12 is the smallest one though. So we haven't done anything to this fraction, so I'm going to leave the numerator as 7. With the first fraction, to make it equivalent, whatever we've multiplied the denominator by, we also need to multiply the numerator by. So if I've times the denominator by 4 to turn 3 into 12, I also need to times the top by 4. On this one, I've times the denominator by 3, so I also need to times the numerator by 3, and that's 9. For the third one, I've times the denominator by 3, so I also need to times the numerator by 3, and that is 3. And with the last one, I've times the denominator by 6, so I also need to times the numerator by 6, and that is 6. And now it's much more simple for us to compare these. So looking at these, I've got 3/12 as my smallest, and I'm just going to write the original fraction. So a quarter first, and let's cross that out. Actually, let's cross out the original so that we don't cross out our working. Then I'm going to have 4/12, so a third is next. Let's cross that out. Next, I'm going to have 6/12, so that's a half, that's next. And then I'm going to have 7/12, and then I'm going to have 3/4 as my final answer. There we go, 2 marks for that one. Question number 10, solve t add t add t is 12. So that's the same as saying 3 lots of t is 12. And if I just want to know what t is, what we do to one side, we need to do to the other. So I'm going to divide both sides by 3. So t equals 4. And then for part B, we are solving x minus 2 equals 6. So when we're solving equations, what we do to one side, we want to do to the other. I would like to get this x on its own, and at the minute we've got x take away 2. So if we add 2, that's going to undo that, get rid of that minus 2. But what I do to one side, I have to do to the other. So x equals 8, because that's 6 add 2. And we can double check that answer. 8 take away 2, that is 6. So x equals 8 is correct. And then for part C, solve 6w add 2 equals 20. So again, I'm going to draw that dotted line, and what we do to one side, we're going to do to the other. I'm going to start by taking away 2 from both sides. That leaves me with 6w, I've got rid of the plus 2, equals 18. And then we're going to divide both sides by 6. So that leaves me with w equals 3. There we go. Question number 12. AB and BC are perpendicular lines. So perpendicular lines meet at a right angle. Parallel is when they never ever meet and they stay the same distance apart. So perpendiculars like this. Find the value of x. So we know if they're perpendicular, they're going to make a right angle. So we know we've got 25 and 25 so far, and that adds together to make 50. I'm then going to do 90 degrees, take away that 50, and that leaves me with 40 degrees, which must be how big x is if those lines are perpendicular. RS and TU are parallel lines. PQ is a straight line. An angle of size 125 is shown on the diagram. Write down the letter of one other angle of size 125 and give a reason for your answer. So you've got a couple of options here. If this angle is 125, so is this one. Now the reason for that is because these two angles, if you go round them both and connect them together, it makes an F shape. And we know that F is corresponding angles. So you could say D is 125 degrees because corresponding angles are equal. That would be okay. Corresponding angles are equal. That's one option. The other option is to look at angle B. And that one is also 125, and that's because opposite angles are equal. So you could also say B is 125 degrees, opposite angles are equal. There we go. Either of those will be fine. You don't need to write them both, one or the other. Explain why A add B add C is 235. So A add B add C is the rest of the angles around that point. And we know that angles around a point add up to 360. So that's what we need to say. Angles around a point add up to 360 degrees, and 360 take away the 125 that we've already got equals 235 degrees. That bit alone is not enough. You need to say angles around a point add up to 360 to get the marks there. Question number 14, work out 1/5 of 70. So with a fraction of a number, you divide by the bottom, and then whatever you get, you multiply that by the top. But we've just got 1 here, so that's going to stay the same. So we're just doing 70 divided by 5. Let's use our bus stop method because we've got a non-calculator paper here. How many 5s go into 7? Well, that fits in 1 whole time with 2 left over. So we'll carry that onto the 0. How many 5s fit into 20? That fits in 4 whole times. So 14 is your answer there. Fiona has to work out the exact value of 48 divided by a half. She says 48 divided by a half is 24. She says there's 2 halves in 1 whole, so there'll be 24 halves in 48. Explain what is wrong with Fiona's reason. So if she's got 48 blocks like this, and she divides them all into halves, she's not going to get 24, she's actually going to get double, she's going to get 96. When we divide by a half, because there are 2 in every whole, we actually get twice as many. So 48 divided into halves is actually 96. Dividing by a half is the same as multiplying by 2. So she's actually halved it, but we want to divide into halves, which actually doubles. Okay, question number 16, and we're expanding brackets here. So to expand a bracket means to multiply everything in the bracket by what's on the outside. So we want to do 5 lots of 2m and 5 lots of minus 3. And you might want to put a little multiplication sign on the arcs there, just to remind yourself that you're timesing, because sometimes people forget and they add or subtract. So 5 lots of 2m, that's 10m. And 5 lots of minus 3, that's minus 15. So our answer is 10m minus 15. You can't do anything with that. You can't put them together because they're not like terms. One of them's got an m and one of them's just a constant number. And then for part B, we need to factorise. Now, factorise and expand, these are the opposite of each other. So what we're needing to do here is actually put this expression back into a bracket. So what have they got in common? Well, they're both in the 3 times table. They have a common factor of 3. So we're going to put that on the outside. 3 times what gets me 3n? Well, I would need that to be an n. 3 times n is 3n. And then 3 multiplied by what is going to get me 12? I need that to be 4. And we can double check that. 3 times n is 3n. 3 times 4 is 12. So that's factorising. We're putting it back into a bracket. Expanding and factorising are the opposite of each other. Question number 18. The diagram shows a rectangular garden path. It's 600 centimetres long and 120 centimetres wide. Wasim is going to cover the path with paving stones. Each paving stone is a square of side 30, and each paving stone costs £2.50. Wasim has £220 to spend on paving stones. Show that he has enough money to buy all the paving stones he needs. So firstly, we want to say how many paving stones are going to fit in each direction. So I'm actually going to divide each side by 30. How many 30s fit into 120? Well, 30, 60, 90, 120. So we would actually fit 4 rows of paving slabs going that way. That's drawn terribly, but there we go. We'd fit 4 going that way. And then in this direction, if I have 600 divided by 30, I'm going to write it as a fraction just to make it a little bit easier. That's the same as 60 divided by 3, dividing the top by 10, dividing bottom by 10, and 60 divided by 3 is 20. So we would fit 20 going this way. I'm not going to draw them all in. So therefore, I've got 20 paving stones going across, multiplied by 4 paving stones going up, and that means in total he needs 80 paving stones. We now need to do 80 multiplied by £2.50 to get the total cost. Now, I think the easiest way to do that is to use your lattice method. So remember, if I want to do £2.50 times 80, I'm going to do 3 boxes going across, 2 boxes going down, so £2.50 times 80. Every single box gets split diagonally, so split it from top right to bottom left and make it a little bit longer on the ends. Okay, 0 times 8 is 0, so we put 0 times 0 there. 0 times 0, well, that's also 0, so we put 0, 0 there. 5 times 8, that's 40, so I'm going to put 40 there. 5 times 0, that's 0, so I'm going to put 0 there. 2 times 8, that's 16, so 1 6 like that. And then 2 times 0 is 0. And then we just add down each diagonal section like this. So in that first diagonal section, I've just got 0. In the next diagonal section, I've just got 0. In the next diagonal section, I've got 0. 6 add 4 add 0, that's 10. So 0 carry the 1. And then that's a 2. And because this is £2.50 times 80, we had 2 numbers after the decimal point in the question. I'm still going to have 2 numbers after the decimal point. So that is £200. So I'm going to say, yes, he has enough money, because we know he's got £220. So he's all good. He's got enough. And that's 4 marks for that one. Question number 20. Here are 2 squares, A and B. The length of the side of square A is 50%. So this is half of this. And they're both squares. So what that means is that I would actually fit 4 of these, because I'd fit 2 of them going up and 2 of them going across if this is 50%, if this is half the length of this one. Express the area of the shaded region of square A, so that, out of the whole area of square B. Now, if I split them all like that, hopefully you can see that that makes sense, that I've got half of one of those quarters shaded. So each of these would be 25%. If you imagine you've got the big square and you split it into 4, that would be 25%, 25%, 25%, and 25%. That would make 100% altogether. If I want the percentage of half of one of those sections, that's going to be half of 25%. So the answer we're looking for here is 12.5%. The other way you could do it is say it's a fraction. It's one section out of 8, and an eighth of 100, you'd need to do 100 divided by 8 times by 1. And again, if you did 100 divided by 8, 8 goes into 10 once, remainder 2. 8 goes into 20 twice, remainder 4. So we're going to carry that onto a 0. And 8 into 40 goes 5 times. So we still get 12.5 that way as well. It's that section out of the whole area. So always draw these things. I find everything a lot easier if you draw. Question number 22. There are only blue cubes, red cubes and yellow cubes in a box. The table shows the probability of taking at random a blue cube from the box. The number of red is the same as the number of yellow, so we know the probability of these two sections are equal. Complete the table. Okay, so probability always adds up to 1. I've got 0.2 so far. If I do 1, take away 0.2, I'm left with 0.8, and I know that the number of red cubes and yellow cubes is the same, and therefore the probability is going to be the same, so I can just divide by 2, and that is 0.4. So 0.4 is the probability of red, and 0.4 is the probability of yellow. There are 12 blue cubes in the box. Work out the total number of cubes in the box. So 0.2 is equivalent to 20%. So I could just say 0.2, which is 20%, equals 12. That might help people a little bit more. So 12 cubes. If I then want to know how many cubes there are altogether, I'm looking for 100%. I want all of the cubes in the box, or 1. Okay, and that would be multiplying by 5, so that would be 60. That's one way of doing it. The other way of doing it would be to say, well, if I know that this is 12 cubes, and that has a probability of 0.2, a probability of 0.4 would be double as many cubes. So that would be 24 cubes, that would be 24 cubes, and if you add all of those together, 12 add 24, add 24, that is also 60. So a couple of different ways you could do that one, but 60 is your answer for 2 marks, however you did it. Question number 3, find the highest common factor of 72 and 90. Now we could list all of the factors, all of the numbers that go into 72 and go into 90, and look for the biggest one that they have in common. But because sometimes we have to do this as prime factorisation, I'm going to practice that method just to revise it. So 72 is 2 times 36. You could do 8 times 9 or anything you like, but if you get to a prime number, you're going to circle it. You'd get the same answer no matter what. 36, I'm going to do 6 times 6. Neither of those are prime. So 6 is then 2 times 3, and the other 6 is also 2 times 3. So 72 is 2 times 2 times 2 times 3 times 3, or 2 cubed times 3 squared. For 90, I'm going to do 9 times 10, 3 times 3, and 10 is 2 times 5. There we go. So 90 is 2 times 3 times 3 times 5. Fabulous. So looking at both of those, I'm then going to do a Venn diagram. And if you want the highest common factor, we're just going to multiply together what ends up going in the intersection, in the middle bit of the Venn diagram. Now, what can I put in the middle? I can put a 2 in the middle because they both have one of those. I can put a 3 in the middle because they both have one of those. I can put another 3 in the middle because they both have another 3. Now there's nothing else in common. With 90 I've got 5 left to go on the outside, and with 72 I've got a 2 and a 2 left here. Your highest common factor is all the numbers in the middle multiplied together. So 2 times 3 times 3 is 6 times 3, so 18. If you wanted the lowest common multiple, the first number in the 72 and the 90 times table, you would take that 18 and multiply it by any numbers left on the outside. So I'm going to times by 2, which is 36, and then times that by 2 and times it by 5. So I've got 2 and 2 and 5, 2 and 2 and 5. Those are the numbers left on the outside. I know that 2 times 5 is 10, so that's probably going to be the easiest way to do it. 360 is your lowest common multiple. So if they'd asked you for the lowest common multiple, you'd have to times all the numbers in the Venn diagram together. In this question, they just wanted the highest common factor, so it's just the numbers in the middle of the Venn diagram, and that is 18 multiplied together. Wonderful, 2 marks for that one. Question number 5, and we have some transformations. It says shape A can be transformed to shape B. Now, transformed is the name of all of them. Remember that transformations, you've got rotation, you've got reflection, you've got translation, and you've got enlargement. Don't confuse transformations with one of those. It is the name of all of them. So we've got rotation, reflection, translation, and enlargement. Shape A can be transformed, so by one of those, to shape B by reflection. So reflection is the transformation that we're looking at here in the x-axis, followed by a translation CD. Okay, so first we're going to reflect A in the x-axis. This line here is your x-axis, but remember, if you wanted the line x equals 1, it's the line that goes through 1 on the x-axis and it goes the other way. But for this question, we're just looking at the x-axis. Your 2 squares up, so we're going to reflect 2 squares down, and your triangle is 3 tall, 2 wide, and goes there like that. So that's shape B. Shape A can be transformed to shape B by a reflection in the shape... Oh, that's not shape B. That is almost shape B. We've got to translate it now as well. So we've reflected it, and now we've got to do a translation. Now, translation is when it's just moved. Your top number in this vector is how much it moves left and right. Negative is left, positive is right. And the bottom number in the vector is how much it moves up or down. Positive is up, negative is down. So we want to move it. I'm just going to pick a point. Doesn't matter which point you pick, but you need to go to the same point on the other shape. We need to move it 1, 2, 3, 4, 5, 6 to the left and down 1. So left, we're going to use a negative number, and down, we're also going to use a negative number. So this is going to be minus 6, minus 1. We never put a line. It's not a fraction, okay? Never put a line, just top number, bottom number. Minus 6 is the value of C, and minus 1 is the value of D. Question number 7. Here are 2 rectangles. Q to R is 10. I like to draw it on. As soon as I know what something is, draw it on because it might help you. And it says that BC is equal to PQ. Now, I don't know how long that is, but I'm just going to call it X. I'm going to say this is X and also this is X. B to C is the same as P to Q. So I'm going to call them both X so I know that they're the same. The perimeter of ABCD is 26. So this shape has a perimeter of 26 centimetres. And this shape, the area of PQRS, is 45. Find the length of AB. So I don't have enough information in this triangle to get that perimeter being 26. I don't know anything yet. But in the triangle on the right, I know that if the area is 45, it must be x times 10, because area is base times height, to get 45. So therefore 10 times x, or 10x, equals 45. Dividing both sides by 10, we can see that x is 4.5. There we go. So x is 4.5, and I'm going to pop that up there. And if I know that x is 4.5, then I also know that this one is 4.5 because we were told in the question that they are the same. Great. This is a rectangle, so this one must also be 4.5. And then let's call this y because this is what we're trying to work out. We've got to find out the length of AB. I now know that 4.5 add 4.5 add y equals 26. The distance all the way around the outside of his shape, that's the perimeter, is 26. So 4.5 add 4.5 is 9. 9 add 2y is 26. Taking 9 away from both sides, 2y is 17. And then dividing that by 2, 17 divided by 2, well 16 divided by 2 is 8. 17 divided by 2 is 8.5 centimetres. So that is your length of AB, 8.5 centimetres. And there we go, that's the end of the paper. So I hope you found that helpful. If you've got any questions, please let me know in the comments. I'd be happy to help. And I would see you guys next week for another paper.